Hello everyone. So today we are going to be looking at June 2023 Maths paper 1 with mechanics, and we're looking at just question 1. And as usual, question 1 is always partial fractions. So before getting into the GCE hall, you need to know your various partial fractions, how to decompose them, and basically how to solve any partial fractions. So in this paper 1, in this question, we have been asked to look for the value of P and Q. Now there are several ways in which you can go about this. If you're smart enough or you do not have time in the exam hall, what you can do is to simply pick out values. Like let's assume that the correct answer is A, right? Meaning that P is 3, negative 3, and Q is 4. You simply insert that in your solution, right, in the equation above. Then you look for you assume x to be an arbitrary value, let's say 1, and you put in the equation. If at the end of the day the right hand side is equal to the right left hand side, that's your solution. But if that's not the case, then you go to the next answer and you do the same thing. I'm going to solve with the two methods and then you see the difference. For the first method, which is the most accurate method, means you know what you're doing, is to simply look for the values of P and Q, right? So we know that when a partial fraction is given to us, let's say x all over x plus 3 and x plus 4, all of these are all linear functions, right? So since they are all linear functions or linear expressions, we can write them as P all over x plus 3 now plus Q all over x plus 4, right? Basically that's what the equation has done. So that simplified it for you. So what you need to do is to look for the LCM here, and then you equate the two. You equate both the numerator with the numerator and the denominator with the denominator, right? So here the LCM is simply the product of these two, right? So meaning that we can express this as x plus 3 multiplied by x plus 4, right? Now here, right, when we take all of this divided by x plus 3, we'll be left with x plus 4, right, multiplied by P. So it will be P multiplied by x plus 4, and here will be we do the same thing, right? This will cancel, we are left with x plus 3, so it will be Q multiplied by x plus 3. Now what do we notice, right? If we look at the left hand side, right, we have x plus 3 and x plus 4. We notice that this and this are all equal, and according to the equivalence of fractions, if two fractions are equivalent from this, right, if we notice this is the equivalent sign, right? If two fractions are equivalent, then the numerator should be equal to the numerators and the denominator should be equal as well. So meaning that our x here should also be equal to P into x plus 4 plus Q into x plus 3. That's basically what this means. And if you want to take that into context, cross multiply, you notice that this will cancel with this, right? And there will be no need for you to assume. When it cancels, you are left with just this. Now this is where it gets interesting. From here, you can decide to look for the values of P and Q, right? How can you do that? Method 1 is actually expanding this function and then equating the coefficients, right? Or method 2 is assuming the values of x. You can say let x be 0, then you have your first equation. You say let x be 1, you have the second equation, you solve them, right? We're going to do the two methods. So for method 1, right, we're going to equate the coefficients. We'll equate the coefficients of the variables. Now I'm going to explain what I mean by equating the coefficients. On the right hand, on the left hand side, right, we can write this as 1x plus 0 to be equal to, we can express this as px plus 4p, right? And we can express this as plus qx plus 3q, right? Notice what I'm trying to do. 1x plus 0 to be equal to, we notice there is an x here, right? There is an x here, right? And there is also an x here. So meaning that we can write this as p, right? Well, we can write this as px plus qx. These are all terms in terms of x. Then the constant should be 4p plus 3q. These are all the constant terms, meaning that 1x, right, plus 0 should be p plus q, right, all that x. You notice what I'm trying to do? Then plus 4p plus 3q. This is the constant term, meaning that this will be equal to 1 since x is equal to x, right? And 0 should be equal to all of this. That's the whole idea behind this method. Now, once you do that, right, meaning that p plus q will simply be 1. That's your equation 1. And 4p plus 3q should be equal to 0. This is your equation 2. Now, to get your value, you can say from equation 2, what do you notice? That 4p should be minus 3q, right? And p will simply be minus 3 on 4q, or q should be minus 4 on 3p, right? You can call this equation 3, and then you say 3 in equation 1, right? So if you put equation 3 in equation 1, meaning that anywhere we see p, right, anywhere we see p, we can replace it with our p here, meaning that we can have minus 3 on 4q plus q. This will give us 1. In this case, well, it's going to help us get the value of q. We can rearrange this as q into 1 minus 3 on 4. This is just to help us see how to easily compute this, right? So meaning that q should be 1/4. That's really the simplification of this. You look for the LCM. You know, this primary school, this implies that q will be 4. This is the value of q, right? Then remember that we saw that p, right? We saw that p is negative 3 on 4. So we know that p is negative 3 on 4, meaning that p will simply be negative 3 on 4 multiplied by 4, which implies negative 3. Therefore, this is the value of p, and this is the value of q. We simply need to look for 4 and minus 3. So q is 4, q is 4, q is 4, and p is minus 3. So our correct answer is A. And remember, this is our method 1, right? If you are interested in looking for method 2, then keep watching. But if you're already satisfied with this, you can move to the next video, or you watch something else, or you use our AI. Now, for method 2, as I said, for method 2, what you need to do is to assume, or just assume values of x, right? Values of x that make sense. Now let me just create some space here. Like, method 2 is actually very short, right? Let's assume that, okay, we are at this level. To solve our method 2, we are at this stage. P into x plus 4, right, plus q into x plus 3. This method, the first method, is very good for paper 2, and method 2 is good for paper 1. Now for the second method that I said, we are going to assume values of x, right? We can say, first of all, let x be 0. And it is very obvious why I want x to be 0, because everything will just cancel out. If you are in a situation where, let's say you have, let's say, p on x, you cannot let x be 0, because anything divided by 0 is undefined. So you need to look for the value of x that makes sense. And you cannot say let x be 1000 or 100. It's going to give you the answer, but you're complicating your life. You get a point. So you need to look for a value of x that is very simple to compute, and that makes sense. That's why in this case I decided x to be 0. So meaning that we are going to have 0 to be equal to 4p, right, plus 3q. What do you notice? This is similar to the equation that we had down here, right? It's similar to this, to our equation 2, right? But we don't have to go through all of this stress. You just have to assume, right? And you'll be able to get the answer, which is a very cool method. So equation 1, then you assume again let's assume again the value of x, right? Let's say x to be 1, right? Let's let x be 1. So if you put 1 there, it can be anything, as I said earlier. So meaning that 1 should be equal to 5p plus 4q. I'm sure this is different from what we had earlier, but no problem. We are going to have the same answer, trust me. So we notice here that when we assume x to be 1, we have that. Then look at it. If we assume x to be that, oh, one thing, we could assume x to be something like -4, right? Anyways, let me just solve with this and I'll show you what I mean. Let's see. Actually, right, the best way the best thing to do is to assume x to be -4 or -3, so that it should initially it should already eliminate one of the values, right? So meaning that -4 here should be 0, right? P will be 0 because we have p into -4 plus 4 and plus q into -4 plus 3. We notice that this is 0, so -4 should be equal to negative q, right? So meaning q should be 4. As simple as that. I think that was the best method. Let's see. We assume we already saw that q was 4, so we are already correct. You get a point. And from here we can easily get the value of p from simply substituting it in equation 1 here, in this equation here, right? So meaning that 0 should be equal to 4p plus 3 into 4. What do you notice? 4 is common, right? 4 can cancel, so p will be -3. As simple as that. Now notice that if you assume x to be -3, it's still going to work, and I'm going to leave that as an assignment, so feel free to do that. And if you come up with the same answer, you can put that in the comment section, or just simply comment that in any of the KET Academy WhatsApp groups, and yeah, you can share that in the group or in the comment section. So that's it for this video. The whole aim is actually taking just a single question, simplifying it, giving you the solution such that if you come across that question in your exam hall, in any mock, or in any paper at all, you'll be able to solve that. And basically this is the approach you need to take when dealing with partial fractions. And this is how I'm going to be breaking down all the other questions into these very understandable pieces. I hope so. So if there's something I didn't mention, or there's a different approach you appreciate, let me know, and we'll see how to incorporate that in the videos. So with that said, we're going to end here for today, and see you in the next video.